All right, let's look at the homework 7.3, problem number 4. All right, so let's evaluate this integral using trig substitution. All right, so in this case, so we have a square root of x squared minus 81 is 9 squared. So this is the secant one. So let's do that. So you have a let x be 9 secant of theta, right? So if you take the derivative, you're going to have a dx over d theta is equal to 9. Derivative of secant is a secant of theta times tangent of theta, right? So we can simply multiply through by d theta. We have an expression for dx. So dx is 9 secant of theta times tangent of theta d theta. All right, so I'll do the substitution. So this is going to be equal to integral. All right, so if you plug in, so 9 squared minus 9 squared here, so you have going to pull out 9, right? Then if you put the secant squared minus 1 is going to be equal to tangent square, so with the square root, so it's going to be 9 tangent of theta. All right, that's square root of x squared minus 81. All right, so then on the bottom you have x cubed, so this is going to be 9 cubed, and then you have a secant cubed of theta. All right, then dx is a 9 secant of theta times tangent of theta, right? And the d theta. All right, so we have that. All right, so let's simplify it. So you have a 9 and 9 squared, so we can cancel 9 up here, 9 up here, so you can cancel that. So you still have 9 on the bottom. All right, then you have a secant there, so secant on top, and the one of them cancel out, so it's going to be, instead of cubed, you're going to have a square there. And then we can combine, there's a tangent here, and there's a tangent here. So that's going to give us a tangent squared, right? So I'm going to write it this way. So we have, there's a 9 on the bottom, so I'm going to put the 1 over 9 outside, right? So that takes care of this 9 right here, right? Then we have an integral. So write the integral here. All right, I'm gonna write tangent squared as secant squared minus 1. So we're gonna have a secant squared of theta minus 1. Right? Then we're gonna divide that by secant squared of theta d theta. Right? So that will take care of everyone, right? So you have a secant square on the bottom. We took care of tangent square, which is the same thing as secant square minus 1. Then we have a d theta. Right? Then we can simplify this. So this is going to be equal to 1 over 9. And this is an integral. Right? Secant square divided by secant square is 1. Then there's a minus sign. Right? Then 1 over secant squared, so reciprocal over secant squared would be cosine squared. So you have a cosine squared of theta, right? And d theta, right? And luckily, we have a 1 minus cosine squared. We have identity, so this is actually sine squared of theta, right? So I'm going to use another identity. Remember that the sine squared is equal to 1/2 quantity 1 minus cosine of 2 theta. So let's go ahead and write that. And so we're going to have, let's see, I'm going to combine 1/9 and then 1/2 together. and you're going to get 1 over 18. Right? Then we still have to integrate 1 minus cosine of 2 theta d theta. Right? So antiderivative is going to be 1 over 18. And antiderivative of 1 with respect to theta is theta. Right, minus antiderivative cosine of 2 theta is sine of 2 theta over 2. And then we have plus some constant c. All right, so all you have to do is rewrite it in terms of x. All right, so let's see. We're going to have to use a little bit of identity here. Sine of 2 theta is equal to 2 sine of theta cosine of theta. So we get to cancel 2 on top and 2 on the bottom. All right, so I'm going to clean up so that I don't get confused. So this is going to be 1 over 18, and you have a theta here, and then you have a minus sine of theta, and then cosine of theta, plus some constant c. All right, so let's start rewriting. All right, so I'm going to work with this substitution equation here. Right, so I'm gonna kind of go down here since there's some room here. So we're gonna have, I'm going to divide through by 9 so that we know that x over 9 is equal to secant of theta. All right, so if you want to find theta, all you have to do is apply secant inverse secant, or arc secant. Right, so you're going to have arc secant of x over 9 is equal to theta. So we found theta. So I'm going to actually go up here. Right, so we have 1 over 18. Then you have, let's see, I'm going to use a bracket here. Right, theta is arc secant of x over 9. Right, minus, right, and let's see, secant is hypotenuse over adjacent. So if you draw a right triangle, right, and this is theta, so hypotenuse, we can set that to be x and adjacent to be 9. So by Pythagorean theorem, opposite is going to be x squared minus 9 squared, which is 81. All right, so if you want the sine, sine is going to be, let's see, opposite over hypotenuse. So it's going to be a square root of x squared minus 81 over hypotenuse is x. All right, then tangent is going to be, actually cosine is going to be adjacent over hypotenuse. So you have a 9 over x and plus some constant c. All right, and we can clean up just a little bit more. So I'm going to distribute 1 over 18th to both terms here. So you're going to get this, it's going to be 1 over 18 times secant, arc secant of x over 9, right? Then you have a 9 and the 18 cancel out, so you're going to have a 2 left over on the bottom, along with x squared, right? Then you have a square root of x squared minus 81 plus some constant c. All right, so let's type it in. All right, so we got the 1 over 18 And we're going to have arcsecant. Let's see if I can do this. Arcsecant of x over 9, all right, and minus square root of x squared minus 81, not like that, minus 81 over 2x squared plus some constant c. All right, let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.